Hello Year 11s, this is our next video based on Hello Year 11s, this is our next lesson. Okay, we're dealing with 16C and average rate of change. Okay, so how do we recognize a average rate of change and how do we calculate it, importantly? Okay, so our learning intention today is to recognize and calculate an average rate of change within a graph. And our success criteria is I can calculate the average rate of change within a graph. So I can calculate and I know how to work that out. Okay, so the average rate of change, we have a graph here. Okay, so what we've got is points A and B. Okay, our red line is our actual graph. Okay, that's our y equals f of x. Okay, so the red line's our actual graph. The blue line is what we do to connect it, to try and find our average rate of change. Okay, what we do is, if you notice with this curve, the gradient's a little bit steeper here. Okay, so I probably should use a different color than red. I might use green. Okay, so right here, the slope is a little bit steeper. Okay, so it's steeper than what the blue line would be. Here is probably, if I can draw a straight line, probably on par with where the blue line is, and right here it's a little bit flatter, so the gradient's not quite as large here. So what, if you think about it, 3 stages, you've got one where it's steeper, a section where it's about the same, and one where it's not quite as steep. This is where we can actually calculate the average rate of change between it all. Okay, and we can use the average as like a baseline of what the rate of change is, or what the gradient is. Okay, so what I've got, so for any function y equals f of x, the average rate of change for y with respect to x over the integral of a and b. So we're dealing with the integral a and b, so that's our domain, so we've got a and b down the bottom. Is the gradient line through a, so a f of a, so we've just found x and y, okay, using a formula, and x and y. So x, think of it as like x1, y1, x2, y2, okay. That is, how we can find the average rate of change is f of b minus f of a divided by b minus a. Okay, so what we've got, if you think about that formula, the average rate of change, that is still our rise over run. Okay, so if I was to break this up into a triangle, okay, right angle triangle, okay, the rise, this rise is the f of b minus f of a, and the run is our b minus a. Okay, so it's just rise over run, that's all we're finding. A couple of quick points down the bottom, just in the red and blue. So the line which passes through the 2 points on the curve is called a secant. Okay, this is the curve section, so that's my curved red part. Okay, we call it the secant. It's that curved section there. The line segment joining these two, so that blue straight line that I've joined between the two, we call it a chord. Okay, and that's a straight line. So, and I've used the colors. So the red is the red line, the blue is the blue line, and that's what they sort of represented. So that's a bit of terminology that we're going to use between the two, depending on which part of the graph we're talking about. Are we talking about the chord, the straight line between the 2 points, or are we actually talking about that curved section that connects them? Okay, and I've listed them there. So the blue is the chord, the red is the secant. Okay, so we've got an example. So it says find the average rate of change from the function x squared minus 2x plus 5 as x changes from 1 to 5. Okay, so what we've got is we need to find f of 1. Okay, so we know that this is essentially our a and that's our b, so we know those two values. I'm going to put a into the formula, or 1 into the formula, to find my f of 1, which is 4. Okay, so 1 squared minus 2 times 1 plus 5 is 4. Then I'm going to put f of 5 in. Okay, and when I get f of 5 is 20. Okay, so to find my average rate of change, okay, I'm going my f of 5, so the f of 5 minus f of 1 divided by 5 minus 1. Okay, which you can see, I just rewrote it. Okay, which is 16 over 4, which is 4. So the average rate of change, the average slope is 4. Okay, how we interpret that, remember, so for every 4 that we rise is for every 1 that we run. So every 4 that we rise is the 1 that we run, and that is my average slope. That's connecting those two. Okay. Now I've got a different question. It says the profit made by a company in its first 4 years of operation can be modeled by the profit function P. which P of T is equal to square root T, where profit is P times $10,000 after T years, okay? So what we've got is when we put the time into the formula, okay, we're going to get a particular value, and whatever that value is of P, we need to multiply it by 10,000, okay? Sketch the graph of the function over the time interval and calculate the average rate of change of the profit over the first 4 years, okay? So what we're going to do is we state the formula, okay, I'm going to find the average rate of change over the first 4 years. So we're obviously starting at when time equals 0. So P of 0 is 0. Then we're going to find P of 4, which is 2. Okay. To graph this, that's what the square root function looks like. Okay. So when time is 4 down the bottom, okay, we get P is 2, the profit is 2, and we get our coordinate there at 4, 2. Okay. So what we're going to do is we're going to find the average rate of change. So the straight line. So essentially the chord that connects between the two. Okay. To find that average rate of change, it's 2 minus 0. Okay. So remember, we're still breaking this up into rise and run. So that's our rise, and that is our run. Okay, so in the green. So the rise is 2. Okay, so the rise is 2. The run is 4. Okay, so average rate of change is 0.5. So since profit is P times 10,000, the profit is increasing at a rate of $5,000 per year over this time period. Okay, so we've just simply gone that 0.5 times 10,000. So on average, so what we can say is on average, we're increasing by $5,000 per year across the first 4 years. Okay, so what you can do now is you can jump to 16C. Hopefully this makes a bit of sense. Just think about your rise and your run, and one of the formulas that is used quite a bit is our M equals Y2 minus Y1 over X2 minus X1. Okay, so that's a formula that you might be using quite a bit, that you've learned from like year 9, year 10 math, and we're just going to link it into a few application questions. Okay, so good luck. If you have any problems, email me and I'll get back to you as soon as possible. Thank you.